I discuss about a topic Bayesian inference, the meaning, importance, real-life example, and application of Bayesian inference. So, Bayesian inference is a way of making statistical inferences in which the statistician assigns subjective probabilities to the distributions that could generate the data. These subjective probabilities form the so-called prior distribution. After the data is observed, Bayes' rule is used to update the prior, that is, to revise the probabilities assigned to the possible data-generating distributions. These revised probabilities form the so-called posterior distribution. This lecture provides an introduction to Bayesian inference and discusses a simple example of inference about the mean of a normal distribution. The importance of it provides a flexible and powerful tool for modeling uncertainty and incorporating prior knowledge in statistical analysis. It allows for the updating of probabilities as new data becomes available. This means that as more data is collected, the probability of different hypotheses or models can be refined and adjusted, leading to more accurate predictions and decisions. It allows for the incorporation of prior knowledge or beliefs about the system being studied. This can be especially useful in situations where there is limited data available, or when the data is noisy or ambiguous. It provides a powerful and flexible framework for modeling uncertainty and making decisions in a wide range of fields, from science and engineering to finance and economics. An example in Example 1. Comparison of the shapes of relatively more and less informed priors. Example 2. The shapes of likelihood functions for two data sets. The data set with the greatest information has a much greater focus. Example 3. The likelihood is flat relative to the prior, so has little effect on the level of knowledge. The prior and posterior are very similar. Example 4. The likelihood is highly peaked relative to the prior, so has a great influence on the level of knowledge. The likelihood and posterior have very similar shapes. And last, application. Bayesian inference has applications in artificial intelligence and expert systems. Recently, Bayesian inference has gained popularity among the phylogenetics community. For these reasons, a number of applications allow many demographic and evolutionary parameters to be estimated, including bioinformatics and healthcare, Bayesian epistemology and weather prediction.